So until the last class we had studied about atmospheric pressure. What is atmospheric pressure? Why do we not feel it? What are the experiments that can prove that there indeed is atmospheric pressure? But how do we measure this atmospheric pressure? One of the instruments that is used for this purpose is a barometer, a simple barometer. So what is this function of the barometer? First of all, see this atmospheric pressure, it has got different values at different places. You go to a mountain, the atmospheric pressure is minimum, and if you go to at the sea level, that is the ground level in which we stay, the atmospheric pressure is maximum. So it decreases with altitude, as we discussed in the last class. So in order to measure this atmospheric pressure, this is the barometer that we use. This barometer was first devised by a scientist by the name of Torricelli. He discovered or invented this barometer in the year of 1643. It is also called the Torricelli barometer in his honor. So what is the construction of this barometer? Well, first of all, there is this kind of a trough, trough, a kind of a trough which is filled with mercury. Then you consider or you take 100 centimeter long tube with a very uniform and narrow bore. In that you fill it with mercury. Then you press your finger at this end and invert the tube into the trough. So what happens is, based on the atmospheric pressure at that place, the mercury flows down into the trough, leaving a vacuum in this upper portion. This vacuum is known as the Torricellian vacuum. This empty space. And the height of the mercury column above the free surface of mercury in the trough is 76 centimeter, because the 76 centimeter of mercury gives an indication of the atmospheric pressure at that place. So that basically means that whatever is the atmospheric pressure acting on the free surface of the trough, that is being balanced by this column of mercury above. And this comes from that formula which we discussed, that pressure is equal to H rho G. So G is at a place 10 meter per second square, and density of mercury is quite high, 13.6. The density of mercury is 13.6 gram per cc, and height 76 centimeter. So from here, if you multiply it with gravity, which is 9.980 centimeter per second square in the units of centimeter, you will find out the atmospheric pressure at that place, which is 1.01 into 10 to the power 5 Pascal, as we discussed. Now, the important points to see here is that this vertical height of the mercury column above the trough, it is varying from one location to another. But though it is varying from one location to another, it is independent of the shape and size of the tube. No matter what be the shape or size of the tube, the height of the mercury column is not affected by it. It simply gives a measure of the atmospheric pressure at that place. So if I keep my mercury tube like this, it will give a value of the atmospheric pressure. If I keep the mercury tube inclined or bent like this, even then it will give the proper reading. So it does not depend on what inclination you keep. We generally say that the pressure that we feel is the 1 atmospheric pressure, 180 m, and that is equivalent to 76 centimeter of mercury, and this is how it is equivalent. In your book you shall find that they have given a comparative study that why it is beneficial to use mercury as compared to water as a barometric liquid. So what are the advantages? One of the advantages is that mercury has a very high density. Water has only a density of 1 gram per cc. A lower density means you will have to consider a very tall tube. Just to give you an idea, for mercury 76 centimeter is enough, but if it were water, you would have required a tube 10 meter in length just to balance the atmospheric pressure. Second problem is that mercury, it has got a very high force of adhesion. So if this is the tube, the mercury surface is like this, bent, because all the molecules of mercury, they attract each other more than the attraction between the mercury molecules and the glass molecules. Force of adhesion is greater than force of cohesion. But if you take water for example in a tube, you will find that the surface of water is like this, bent in the upward direction. This is because in water the force of addition is greater than force of cohesion is greater than that of addition. So as a result, water is another reason why water cannot be used as a barometric fluid. The second reason is, the third reason is that mercury can be easily obtained in a pure state. You cannot obtain water easily in a pure state. Mainly you will find impurities dissolved into water. And the final and most important part is that in this upper portion, we said no, there is a torricellian vacuum. If you keep mercury here, then this vacuum remains a vacuum, no problem. But if you keep water like this, and if there is a vacuum here, water will start vaporizing. It is one of the phenomenons about the triple point of water. You will do it later on. So if you provide vacuum to water, water immediately starts boiling or vaporizing. So that gives incorrect reading. But even this kind of a barometer, the simple barometer, has got its own set of disadvantages. What are the disadvantages? Well, first of all, as you can see, these areas, they are open. They are directly exposed to air. So there are chances that impurities can get mixed with the contents, and there can be contamination which will give us wrong results. Second, as you can understand from this structure, it is very sophisticated. It cannot be moved from one place to another pretty easily. There are all kind of fluidy things, and you know how difficult it is to move certain things like this. They are not rigid. And finally, this is not compact and portable. In order to overcome these shortcomings, one of the solution was finding out an aneroid barometer. Another thing was also found out, which is known as the Fortin's barometer, as you shall study in class 9, which is something much more compact and portable. But what is this aneroid barometer? It is more like an altimeter. Like, it helps you to measure the pressure at a certain altitude. Pilots who fly the aeroplanes, they can find out what is the pressure at a certain height above the ground by using this kind of aneroid barometers, and they also help you to measure the height above the ground at which you are.